Welcome everyone to our January RAS public talk. It's wonderful to finally be with you here at Burlington House. We've had a bit of hiccups with public talks since we started the season in October of last year. And I know transportation, hopefully you got here smoothly this afternoon. I just want to introduce myself. I am Lucinda Offer. I am the Education Outreach Officer here for the Royal Astronomical Society, where we encourage the study of astronomy, geophysics, and space science. Today, I am excited to introduce you to our speaker, Mark Wrigley, who's going to share with us his experience in education and disruption. Mark is a physicist and a child of the space age, and his enthusiasm for the Apollo space program, intense curiosity and rebellious nature led him to study physics at the University of Leeds in the early 90s. From gas turbine engines to aviation data acquisition, he saw the introduction of digital methods that brought mobile phones to the market. And he's a fellow of the Royal Astronomical Society and the Institute of Physics. He also won an award by the Institute of Physics for his excellent outreach in the Nations and Branches Prize for Excellence in Outreach in 2016. And I'd like to let you know that we are live streaming on YouTube right this moment. And we can take questions there on YouTube. Thank you for joining us on YouTube. And also we have attendees on Zoom. You can leave your questions for Mark after the talk. Use the Q&A icon on Zoom and the chat box on YouTube to post them, which I will be monitoring. Thank you, Pam, for being here to do Q&A later today. And thank you again, everyone, for being here at Burlington House and on Zoom and YouTube. And thank you, Mark Wrigley, for being here. Say it on to you. Thank you.
Thank you. Pleasure. Right, well, it's lovely to actually see real people instead of looking down the camera on the back of my computer. Right, so my name's Mark Wrigley. I've come to talk to you about some of my experiences in outreach. If you ask me to identify myself, I'd say I'm a physicist. Studied physics back in the 1970s, and I then went on to an engineering career and actually a commercial career. So I've sort of had a non-linear career path. And 10 years ago, I decided to retire and also look at what's happened in physics and astronomy since I'd left it, and got very involved in outreach. So never underestimate an old man with a physics degree. I studied physics not because I wanted a good career. I studied physics for no other reason than I wanted to understand life, the universe, and everything. So as a teenager and slightly rebellious, what I was being taught in religious instructions, as we used to have then, just didn't add up. And I decided I wanted to find my own way of working it all out. And I must say, I've now reached 70 years old and I'm still working on it. I've got a few ideas. The other thing I want to say is that I'm not an educationalist. I don't pretend to be. Some of the things I say in this talk might challenge our view of education. So I'm not going to apologize for that. I think challenging things is stimulating. If I upset somebody, that's even better. Right, so this thing about being 70 years old. I had my birthday last September, and it's quite poignant, really, and sadly, the death of Queen Elizabeth II, because I'm very much an Elizabethan. I was born after King George VI had died and before the coronation. I was actually born shortly after the Festival of Britain. In that time, there's been immense technological change. But we all seem to think that technology change is something that's a fairly new thing. So one of the exercises I did when I was preparing this was mentally to say, well, I was born in 1952. So if I go back 70 years, what happened? Well, 70 years ago, they just invented the light bulb, and we were looking at having distributed electricity systems. If you go back 50 years from when I was born, it was the first manned flight. And only 30 years from when I was born was the first broadcast of the BBC and the first broadcast radio system. So things have actually changed constantly, I think, since the Industrial Revolution. Bill Hicks has a lovely saying, because I'm upset about some of these cliches, like what's your journey? So I like to think of what Bill Hicks says, is that life's a ride. And so here's my ride. And I put it up to sort of show you some of the discontinuities and things that changed. And this is the ride that I'd be quite pleased to put on LinkedIn. So what happened? Well, I was managed to get through my 11 plus and went to the grammar school, where I didn't have a particularly nice time because I think people tell me I'm dyslexic, although I've never been tested, but I was always in trouble. I did, however, manage to get the qualifications to get through to go and study physics at Leeds, particularly interested in cosmic rays, and did a cosmic ray project in my final year. I did a little, stepped out of university for a while and came back to Sheffield University. And I'm very proud to say that I have got a degree in light bulbs. I was sponsored by a company who make medical instruments. And at the time, they wanted to have a tungsten halogen light bulb in an ophthalmoscope, so that when you go to see the opticians, he could literally blind you with the amount of light he's shooting into your eye. But it was all about Planck function, and it was also some chemistry about the halogen cycle and keeping the bulb clean, which led very nicely into the first job I got after that, which was putting parameters into aircraft to measure the temperature of gas turbine blades. So instead of manipulating Planck function to create light, I was doing it the other way around, looking at the amount of light that was coming off to work out temperature. And I carried on in that sort of job, and it was a great job. I was project manager. I got customers in West Palm Beach, lots of strawberry daiquiris out there. And I traveled out to Phoenix, Arizona. In 1982, I did my first training course in Xi'an in China. So a fabulous job. Went to lots of engineering meetings, and I kept coming back with orders for more equipment. Now this was a little bit of a problem to the sales department, because they were supposed to do that. So they put a stop to that by employing me in the sales department. So from then on, I had jobs where I needed to have the technical overview, be able to talk properly to engineers, but actually doing sales jobs. And, So the first, and about this time, things were turning digital. So up until then, everything had been analog. If you did a screen grab, you used a Polaroid camera and pointed it at an oscilloscope. So things were moving digital. And I got a job with a company who were interested in something called digital mobile communications. And this actually was the second generation of mobile phones. And this is the point at which mobile phones stopped being completely analog and went digital, which meant they got cheaper and more accessible, and you could get more phones onto a network. And I'm sure everybody in this room is sitting with one in their pocket now. And so I was sales manager. I worked with them to get the first type approved mobile by doing negotiations with Telecom Denmark and getting the first type approval with them. And then I went on to work with them work with the company which was taken over by Ericsson in China, USA, and Japan. So that was a fantastic experience in terms of diversity. Back to England in 1989, we had the National Lottery. Princess Diana had died. We had a Labour administration, and we had the Spice Girls, and I thought it was time to come back because my country really needed me. So my job then was to be a product manager. So that is to take a part of the business and run it like a business. So take a product and run it like a business. And I was involved with a part of the mobile phone network that controls what all the base stations do. And we're working in multinational teams, really exciting stuff. I was talking to teams in Beijing, Ireland, Chicago, and working together to deliver those sort of things. So then 10 years ago, I decided it's retirement time or semi-retirement. And I set up a little company. I started volunteering a lot for the Institute of Physics and doing outreach. And I'll talk about it a little bit more, but it's upon this idea of a DIY telescope, which I've used in outreach. So that's the ride as per LinkedIn and what I'd like people to see. There are things which really drove my enthusiasm when I was young. And I put some of them up here because they sort of resonate later in life. So the first thing that happened that I was very excited about was around about 1955. My parents got a television. And we all take it for granted now. But back then, some people didn't have a television. And to me, and probably dyslexic child, being able to see documentaries on TV was fantastic. The things that I got into when I was little was that you may remember there was a construction toy called Baco, which is a bit like Lego, which involved following fairly detailed plans, making electromagnets, airfix kits. So around about 61, something happened, which I just assumed until 1961 that we went into space. I'd watched all the films on TV, and I just assumed it was real. And then Yuri Gagarin did his first orbit of the Earth, and I realized it wasn't. And that somehow seemed even more exciting. So I continued doing this sort of stuff, building radios as I got older, hi-fi systems. I was really intrigued. Meccano magazine ran a thing, how to build your own computer at home. And this was 1967, and before microprocessors and all that. So actually what it was just a register. Just an adding machine that they built with light bulbs and transistors. But that sort of caught my imagination. And then 1968, Christmas, I'm sure everybody in this room remembers Apollo 8. I was absolutely intrigued by this. And this was such an event. And I wanted to record it all. I was like, there was no domestic tape video recorders or anything back then, no internet, obviously. So I decided I'm going to record this. So I borrowed my father's reel-to-reel tape recorder to record the sound, and even borrowed his 8mm cine camera and started filming the television screen. So in fact, this archive was used for the 50th anniversary at the National Science and Media Museum in Bradford. And they did a display of some of the artifacts I'd collected at the time. And I'll let it play it. So this is the sort of image. I'd found a company in Germany who sold black and white movie film, which was 400 ASA as it was in those days, but 400 ISO. And just by positioning the cine camera in front of the TV screen. And it looks exciting, but actually I remember the moon landings and it really was boring. I think I sat up for 4 hours to get a couple of minutes of film, waiting for them to come out. And so this was the launch, and as it was recorded from BBC on a 405 line TV set with 2 channels. So I'll move on. So after the moon landings, the things that really got me excited, when I was studying light bulbs at university, I got into microprocessor development boards. And about that time, some of the first home computers were coming out, which was a Tandy TRS-80. A little bit later, actually, in the 80s, the company that I was working for doing these parameters was a traditional aviation company and did not have computers. So I got into computing on a Commodore 64, and I was actually using a 200-pound computer that I'd bought myself to do things like numerical integrations of ray tracing. So there are fighter aircraft flying around, thankfully in the USA, that have probably got my bits designed by a Commodore 64. And I can't leave this sort of influences without talking about Zen and the art of motorcycle maintenance. So this is a book I read when I was at the university the second time round, and suddenly it made everything fall into place. I could spend all day talking about it, but basically it talks about quality in what we do. And it talks a little bit about gumption. And one of the things that I've sort of come to realize in outreach is what I'm trying to do is to develop some gumption. So another influence that I think is worth mentioning was this guy who did a TEDx, or sorry, a TED talk. I think he actually ended up being the winner of all the TED Talks in 2013, but he basically discussed why do we do education like we do? And his comments were, we do it because we used to have an empire. We used to need people who could write things down, organize, record, communicate through paper, pencils, arithmetic. And that's why, in his view, why education is like it is now. And he goes on in his talk to say what he did in India. And he took some computers and he put them on the street, put a screen up so that street kids could play on these computers on the street, but he didn't give them any instructions. And he found that they actually not only learned how to program these computers, but they also taught themselves English so that they could understand the operating language, which was written in English. And I thought it's quite, if you get the chance, it's certainly worth looking at his talk. So why do we do outreach? Well, there are lots of reasons. So I've worked with the Institute of Physics and we've done a lot of outreach. And there are good reasons. So one is it makes your organization look good. It makes you look democratic and open to people. That's good. In some cases, particularly with some of the things I've seen with the Institute of Physics, it's good for undergraduates. So we get undergraduates out, they get some experience in communicating with people. They get something they can put on their CV. Good, like it. My personal reason for wanting to do outreach was to empower people to get better jobs. So I'm one generation away from a coal miner, and I actually found having a physics degree was a very powerful thing to have in business, even in commerce. I mean, you put a physicist in a room with an accountant and they will run circles around them. So this is one of our outreach activities. This is the Arctic Science Fair a few years ago. And the trick here is to get one of these plasma balls and put a fluorescent light tube near it, and the light tube lights up. And the kids go, wow. And we then moved on, because what I was a little concerned about in our outreach is that that's great. Somebody comes along and goes, wow, and walks off, and you never see them again. So we want to engage them a little bit more. So the next idea we came up with was this thing called painting with light, where you get some colored LEDs, you go in a blackout tent, do a picture, and you actually get this tweeted to you when you leave, so you can pick up your picture on a tweet and see what you did. It gives a little bit more time and talking about what we're doing and so on. And then we got hit on the idea, well, how about making something? How about we get people at science fairs and we sit them down and we give them an activity that lasts 15, 20 minutes, and we even give them what they make and let them take it away. So we found this company in Sheffield who make these toys, and through negotiation, we were able to get these kits for about £3 each. They normally retail for about £20 when they're in a flashy box. But in a packet like this, the guy was able to sell them to us. Now, I've used this many times and I'm really quite pleased with the results. We started actually putting a few keywords on the base of this thing. So things, you know, like mechanical advantage and all that sort of stuff. I got a feedback from one of the parents and they said, look, what you did is great. She's come home with it. This thing is now on our mantelpiece. So that I'm pleased about that sort of level of engagement. This is another thing that we did. Originally, this was a demo. This is called the battery train. And basically, you wind a copper wire around a piece of dowel, and then get these very powerful magnets on a battery, and the opposing magnetic fields from from magnets and the field generated by the battery makes the thing travel along. And this is a little video of a young man doing it at the Oxley Science Fair. So I was going to say he's wound his coil and he's now going to get his battery train to work. In fact, he was quite enterprising. He delegated winding the coil to his mother because it was boring. But then he's got the idea now, and he's got the idea, oh, well, what if I put it in a circle? So now this is sort of what I'm wanting to stimulate. I don't want to give you instructions what to do. I want you to find out. And then I think at the end of this, there's an adult playing with it next to him, and he wrecks it. So I think they get their magnets stuck together. So this all got me thinking from cross-fertilization of what I used to do in sales. So in sales, we have this thing called a funnel. And if you're into education, it's sort of like an upside down Bloom's taxonomy. And in sales, you do this stuff, so you go looking for people who might want to buy anything. In the sort of sales I was doing, that actually usually involved soliciting an invitation to tender and writing an offer, and then going out and negotiating it, and eventually you sell it. And it's called the sales funnel. And there's a lot of stuff about forecasting and where something is in the sales funnel, and lots of different companies have lots of different ideas of what they should look like. But I thought, well, what about we apply this idea to what we're doing in outreach? So, you know, the wow bit is what you do at science fairs to get people involved. Then you engage them a little bit more, and maybe you sit them down and get them to make something under instructions. And at the end of it, what I'd really like to happen is that they start looking at inventing something themselves or self-teaching themselves. And this is where I'd like this word gumption. So we're actually inspiring some gumption. So having said that, and I think I have to sort of say life is non-linear. While all this was going on, I got quite excited by a couple of things based on those early rides that I'd shown you. There was a company, sorry, yeah, I just mentioned, Sheffield University has a thing called the Festival of Mind, which they run every 2 years. And they offer grants for people to do public talks. And I wanted to talk about a couple of things that I found particularly exciting. So one, and then we're going back 8 years, was this thing called the Raspberry Pi. Now, the Raspberry Pi is a little computer that you plug into your television for a screen. You plug a keyboard and a mouse into it, and you've got a little computer, and it comes with lots of stuff to do, Minecraft and so on. And to me, this was just like a rerun of the Commodore 64 days or the early 80s Sinclair computers. It seemed to be exactly the same thing, except this particular thing cost about £30. So it was really exciting. Now, I think on this slide, they're talking about it, they're publicizing it because it's sold 1 million units. On the way down here this morning, I checked, this computer in its various guises has now sold something like 30 million units. So it's a massive thing. And even more exciting for me, after my sort of early photography experiences, this thing comes with a camera. So for another £15, you can buy a little camera and take pictures with it. The other thing that was around and breaking onto the scene 8 years ago was 3D printing. And this printer here is actually called a RepRap Mendel 90. It's a 3D printer that's manufactured by 3D printing the parts. And so these two things were to me, quite exciting. And I thought, well, what could I do in a talk for Festival of the Mind to get this across to amateurs and citizen scientists and tinkerers at home. So I came up with the idea of combining it all into a telescope. And we put forward a proposal to Festival of the Mind, and they accepted it. And they actually, being a Yorkshireman, they funded my purchase of a 3D printer, which was very nice indeed. So let me explain what we did with this telescope. So top here, you'll see the normal Newtonian 3D printed, sorry, 3D, yeah. Sorry, what's my time? Right. Okay, is it because I'm using the cursor to point? Right, is it on there as well?
Yeah.
Okay, right, sorry about this. Right, classic Newtonian telescope. I think everybody probably knows how it works. You have a concave mirror which forms an image. Use a 45-degree mirror so you can look at the image, and you use an eyepiece to examine the image. In fact, unless you're Herschel, who hung over the edge of his telescope. So what we did here with the 3D printed telescope is we took the little camera that came with the Raspberry Pi, took the lens off it, and effectively used the concave mirror as a lens for the telescope. And this is what the camera looks like. So the size of this is just an inch or 24 millimeters square. That's for the printed circuit board. In the middle, there's a little sensor. The one we started out with was a 5-megapixel camera, and the size of that is 2.4 by 3.6 millimeters. So we put that at the focal point, and we put a rack, in fact, yeah, we put a rack so we can move it backwards and forwards and focus it. So I just want to sort of quickly talk about the Raspberry Pi. This is the Raspberry Pi that we used. And if you're not familiar with them, I'll just sort of explain what you get with it. So as I said, you need to plug it into a monitor or a TV set. So there's, on this old version, there was a composite video output and an HDMI connector. There's a USB socket here on this side. Oops. Right. So there's a USB socket on this side for the keyboard. On this side, there's an SD card, like a camera card slot, which is the memory that contains the operating system. At the top here, there's lots of input-output devices if you want to control things. That was 8 years ago. Since then, there have been various iterations of the Raspberry Pi computer. It's got the actual, if you buy a Raspberry Pi, we're now up to a Raspberry Pi 4, which is quite a sophisticated computer. It can do things like run Windows 10. But also they brought out a couple of cheaper models. So I put up here the Raspberry Pi Zero, which was brought out a few years ago. When this came out, it was £3.50. So it makes it very accessible. Right, I'm just going to explain a little bit about 3D printing. So this is the 3D printer that we used. What you have on the top is a reel of plastic, which is going to get melted on this nozzle, which is behind here. The nozzle's on a gantry, which moves up, well, when you start printing, it moves down and then slowly moves up. And at the bottom, there's a hot plate that can move in the X and Y direction. So 3D printing this way is very much based on a Cartesian geometry idea. You have a base plate that's moving in the X or Y direction, and your nozzle is putting down the plastic. And when it's finished doing one layer, which is a 1/10 or a 1/5 of a millimeter thick, the whole thing moves up and it does it all over again. So the analogy is it's a bit like icing the cake. So you do one layer and then you keep icing, and instead of having a square, you'll start to build up a cube. So to actually design and print something with a 3D printer, you have 3 stages. The first is you actually have to design what you're doing. So you use some sort of computer-aided design package. And the one I've got here is called Tinkercad, which is a very simple, quick-to-learn method of designing something. But once you've got that design, you have to convert the design into a set of instructions that the 3D printer understands. And you do that by a process called slicing. So the thing I use now is something called Cura. And I'd just like to say, all these things I'm showing you are free of charge on the internet. You don't have to pay for them. And then once you've sliced your design, you have something that's written in G code, which is the instruction set for the printer, and then you go out and you print it. So going back what we were doing 8 years ago, here's our printer. It's arrived in pieces. It took about a week to construct. Had to do things like leveling the bed with a gauge, and then we started printing. So the way we did this is we took a G code that was supplied with the printer. So we didn't start trying to design anything. We just took a G code that was with the printer and just to see if we could print something. And it took quite a few attempts. We got a lot of spaghetti, but it took quite a few attempts to get something that printed and stuck to the bed. Usually what was happening was that the thing wouldn't stick down to the bed. We got a load of, well, as you can see, spaghetti. So once we got that, we knew we could print something, the next thing we did was we thought, well, we'll try and slice something and print it. So there's a website called Thingiverse, which is a place where people can put their designs and you can print them. So we took a design, and I'd got a friend who was particularly into steampunk. So we decided to print these steampunk goggles by downloading the design that somebody had already done and slicing it. And sure enough, we got a pair of steampunk goggles with, it uses camera filters for their lenses. So then the final thing was to start designing pieces and taking it through the process. And at this time, I was using a package called FreeCAD. And again, it's an open source, free package. And designing, this is the prototype mirror mount. And the real thrill is to have designed that in the morning and have it in your hand in the afternoon and not leave your living room. So quite exciting. And here's the prototype telescope. You can see at the front that we've got a rack, and in the prototype we use Meccano bits, basically just to move the camera backwards and forwards so we could focus. And in terms of what we could expect to get out of it, one way of thinking, if you're a photographer, is that this is what the various handles you get with different lenses. So a piece of 35mm film is 36 by 24 mil. What we were using as a sensor was a 1/10 smaller. So we could expect something like the total length of the mirror was 500 mil. So you could expect something that would be equivalent to about a 5,000mm camera lens. The other way we looked at it is, and I had to go back to school, I couldn't remember my trigonometry, but the arctan of 2.4mm over 500mm gives you a field of view of about 1/4 degree. And as the moon subtends about 1/2 degree at your eyeball, if we use this telescope, you'd expect to be able to get about half the moon at a time in the field of view, which is what we got. So when all of this was going on, this was all heading up to a talk at in Sheffield, and they have this Spiegel tent. We were under quite a lot of pressure actually doing the project because we'd made the telescope work, and I was quite happy to point it across the street and look at a brick in the building across the road. And the university had employed a public relations company who was sort of saying, well, yes, it's great, but we'd like some pictures now. And so, and I'm sort of saying, well, what don't you understand, that it's cloudy every night, or that the moon's in the wrong place? But we did actually get those pictures about a week or so before we did the talk. And we did the talk in the Speedle tent, and I thought that was it. So I'd done my bit, I'd done my project, I'd learned 3D printing, and then this happened. So after the first talk, which incidentally was on my birthday 8 years ago, I got a call. I was having a pizza. I got this buzz saying, "Have you seen the BBC Look North website?" And slowly this thing got into all the mainstream press. And, you know, it was presented as, you know, the first 3D printed telescope and all that sort of stuff. And we had a little website. In fact, the website's still going. So as you can see, in July and August, before there wasn't much happening on the website, suddenly the website had 9,000 views and getting a lot of attention. And at that point, somebody said, well, why don't you crowdfund this? Why don't you get this out to more people by offering it as a crowdfunding package? So like a kit of parts where you could either just buy the parts that you don't 3D print, you could just buy the mirror, you could buy the whole thing if you've not got a 3D printer and build it. And that's what we did. And we raised about £5,000. And this is the where the first 100 plus PyCons went around the world. So it was not a purely UK thing. Once we'd got onto the internet, it was all around the world. And when we'd done that, we decided, well, we're going to make this what's called open hardware, so that the designs are all online. You don't have to come to us to buy the bits. You can go and buy the bits yourself and build it yourself. And when we redesigned it for the crowdfunding, we used 3D printer parts, so they're all readily available. So the cog in the middle is not Meccano anymore, it's a 3D printed part. And the tube is a ventilation duct. I think they cost about £15 with enough to cut 2 tubes out of it. And then I've worked with a company called Sky's the Limit, who import telescopes from China. And the guy there gets me a batch of mirrors now and again. So when we started doing this, we could get hold of mirrors for about £13 each. And when we went into the open source, we then put our products on Thingiverse, so people could download the files. You can go to the web with the PyCon website as well. There are several of these sites now. This one is called Instructables, where you give the full instructions how to do it. So I think it's on about 5 different sites. So in terms of reach with outreach, then this is reaching a lot more people. And then there is now a shop, so you can go to a shop and online and buy the bits that you if you want to. So then it's now a story of how this is beginning to get more and more publicized. So the top of that funnel is how you get this word out to more and more people. Make magazine, which is an American publication, got hold of what we were doing, got in contact with it and said, could we write an article about it? So they wrote an article about it. They also had a couple of their people build one in a half-hour video so people could follow what they were doing. They used to run maker fairs. So this is a place where you could take your equipment, and there's similar projects going on. So we went to several maker fairs. And I had a quick look at what sort of reach we'd got. We've got a PyCon website in total has had 150,000 page views. We've got nearly 700 people following us on Facebook. The video presentation that I did for the Festival of Mine is on YouTube, and that's had about just over 9,000 views. But we also encouraged users to feed back to us. So the first level of feeding back would be, well, show us what you did with it. This is a shot taken by Ward Hills, who runs the Cambridge Makerspace. And I think, given that he's using a 4.5-inch mirror. I think that's really quite good. Had other people with moonshots coming back. And I encourage people to show us their build. So somebody here decided to use a longer focal length lens and build a longer tube, slightly modify the way it's mounted to the tripod and so on. So that was the sort of first thing. We then got people who wanted to add on. So we're moving towards this gumption on the sales funnel now. So not only have they built one of these, they wanted to add pieces to it. So this group called Third Earth Designs at a very early stage, instead of having to have a keyboard and a monitor or whatever you need for the Raspberry Pi, made a little handheld box that you could take outside while you're observing. This gentleman in the USA went even further. He decided to motorize the complete thing so he could sit in his living room and turn it around and move it around. I think Chris Thakin might be a fellow here, but Chris is very much into tinkering, and so he came up with a way of making it a conventional Newtonian telescope with a very clever 3D printed method of adjusting the eyepiece. We were contacted by a group of high school students in Argentina, and together with Sky's the Limit, we sent them enough components to build 10 telescopes. And their idea was they wanted to go out into underprivileged areas and take telescopes to show other people, how amazing it is to look at the sky. So I think this happened a few years ago, and I think they've all moved on to universities now. And then finally, the last few months, I've been working with a group who are in Lithuania, and they are a fabrication lab attached to a school, and they've been doing things like looking how they could laser cut a tripod to fit it on. So it's my sort of funnel of things that happen. So, the awareness level we use with social media, with magazine articles and so on. And then we get people involved with, they'll come on the website, start planning to build, make one under instructions, but then go on to do their own thing and improve it and make, invent new things to do with it. And that's back to my word gumption, I suppose. So how are we doing for right? Not bad. The thing that got me, and I ended up putting this in my master's teacher, is that a person filled with gumption is at the front of the train of his own awareness, watching out to see what's coming on tracks and meeting it when it does. And as somebody who's had a sort of very non-linear career, one of the things when I showed you the timeline of the things that excited me at home, which I was always being told off for because I was distracted from my education, those are the things which are actually really useful to me when I was in the career. So the electronics, the tinkering with computers, all that helped. So life's not linear. So if I can get that slide back, I'm going to say that's all, folks. But I'm all just going to say that's all folks for the PyCon, because we've now done this for 8 years. I've got 15 mirrors left in stock, and it's slowed down, so we're not going to do any more. So if anybody wants to get in touch with me, please do. If they want to take that project further, I'd be happy to help them. And I'm going to move on to other things. So thank you very much for your attention today.
Thank you, Mark. That was fantastic. That was really interesting. And I think the thing I enjoyed all of it, but the one I really appreciate you took the time to do is your timeline. Timeline was fantastic to look at. And I had a TRS-80 when I was a kid. And my father made us, we didn't get a Commodore, which is really cool. All the cool kids had a Commodore, and I got a TRS-80. We had a terrible name for that as well. But thank you so much for being here. We have time for questions. So if there are any questions in the room, please raise your hand. And we have Pam who's helping with the mic. Anyone?
Got one on the Q&A box.
We do have one. I think from Chris, it might be your friend Chris. I'm happy to read that one out. Actually, I had a question as well, which was, because you mentioned, I wasn't around to see the moon landings, not yet. I wish I was, and I'm looking forward to Artemis and the future of when humans again go back to the moon and beyond, because I'm looking forward to humans on other planets in our solar system too. And you mentioned that it got boring, and I've heard a lot of that. So I wonder if you have any advice, in this new time of human space exploration, what would make it more exciting?
Right. Okay. Well, I think what would make it more exciting are things that you can do with the internet and with mobile devices. So back in 1969, the only way you had of getting live coverage of anything was television and radio. What I've been doing, so I've been following the James Webb telescope deployment on various websites that they have. I was able to keep an eye on where it was, what was happening, and everything through some of the NASA facilities. Well, I haven't mentioned this, but I really love social media. I think social media is a bit like the invention of the printing press. You can write bad books and you can write good books. And with social media, you can choose whether to follow somebody who takes pictures of their dinner, or you can follow somebody who's a bit more interesting. So the other way I would follow this is through social media and what other people are saying.
So we have a question from Chris on Zoom. He says, what advice would you have for people who do not have a degree, but that would like to pursue a career in the space industry or otherwise in promoting excitement and interest in people to learn more about space? And he's interested to know from a social mobility perspective, and any specific career paths would be great to know about.
Yeah. Well, I guess what I showed you here were things which were outside my degree. The maker movement. So I have to state an interest here. I'm the treasurer of the Oxley Makerspace, and I see the maker movement as being a great way of engaging people and learning, because a good makerspace will have people who know what to do and are more than willing to show other people how to do it. You can choose your makerspace and be careful. If you want to get into embroidery, you can do it in a makerspace, but also if you want to get into Raspberry Pi computers, you can do it in a makerspace. So that would be one way. And I sort of held back on some of these words. A couple of things I've seen in my career is that I've done things for no reason. And there's a great book called The Luck Factor. Why are some people luckier than others? Because they're prepared, some people are prepared to invest time in things that don't obviously have a reason. But in some cases, it turns out good. So, yeah, it sounds very, I don't want to sound like a therapist, but yeah, do things from your gut. What is it that inspires you? Because there's nothing worse than having a career of doing something that you don't really like.
One of your word gumption, and I was wondering how much of that is courage, because I don't like to think how old I'm getting, but I'm getting old even though I grew up in technology.
Yeah.
And I do have a lot of ideas, as I've talked with you, I'm really interested in tinkering in space industry and in astronomy. But then it's the courage really to put that out there. Yeah. Did you have any things that held you back about failure, perhaps?
I'm happier doing this now. I'm retired. So when I was in some of these roles, it was very objective what we were doing. So we were getting a product out to market, and so you had to work within those bounds. I don't know, there's a lot of people talk about imposter syndrome and so on. I think one of the things I'd like to see happen in outreach is that we build people's confidence to do stuff. You know, that you encourage people to do something different. You know, like the little boy who decides he's going to put the battery train in a loop. Applaud that. So yeah, I mean, I'm not sure. I can't fix the whole of society because there are people in society who would want to control you. I just generally try to stay away from them.
Any questions?
Thank you, Mark. It's very inspiring to hear about your career and your life story. I wonder about the current generation of young children. You talked about the things that inspired you, that gave you the tools to make things that you played with as a child. Do you think the current generation of kids are deprived of that and don't develop those skills because they don't play with Meccano? Well, I suppose Lego, round here, there's a huge Lego store and seems to be very popular. But I wonder whether there is that same initiative and confidence building with hobbies now than there was 50 years ago.
I think it's probably moved on a bit. Certainly, I was very interested in photography and cine photography at the time. Now we've got videos on social media, and that's very popular. And I don't know. I'm not sure if it's who I mix with. When I'm back in the Sheffield area, I know a lot of people who are into media studies or you know, producing film. But now it's not on. It's not chemical analog film. It's that way. What I see of the maker movement and things around it, there's loads. There's a company, again, a Sheffield company called Pimeroni or Pimeroni, who make endless things that you can build. But now it's all moved on. So it's things like you could build your own games console, or you can build some sort of liquid crystal thing that flashes or whatever. So I think it's there. I think it's just different. And I suppose part of the fun for me is not being mainstream. So digging into, so yeah, Lego's still there, and that's pretty mainstream, but digging into these other areas. And again, social media, if you get linked up with the right people, will help you do it.
We have more questions from Lucinda from the Zoom.
Yeah, we have also comments, maybe just enjoying your presentation. You've given people lots of food for thought for the outreach that they do. And also, thank you so much for your varied and very interesting lecture on so many levels. A couple of other questions. One really interesting, is there anything that you are planning to do for people with physical disabilities in this field?
No.
Any other kind of disability?
I haven't thought of that. I tend to sort of think about things which I'm aware of. So I think it's said in my bio, but certainly my son is diagnosed dyslexic and ADHD. So I'm sort of aware of that. I'm also very aware of diversity about ethnic issues. So my late wife was born in India, and my children are of mixed race, and I see some of the barriers that they face. So if somebody wants to get in touch with me and make me aware of what the barriers are, I'd love to go in that direction.
They also say lovely session and thank you very much for a very interesting talk. Wondering what are the things that you are going to do next?
The next thing, right? I have a germ of an idea at the moment, so I'm very interested in bridging the gap between art and science. For a while, I actually got to be physicist in residence at an art gallery. And so what I'm actually interested in next is I'd like to build a XY plotter, or in old talk, a printer plotter, but program that in some way that communicates science, that attracts people in the art world as well. So I've got a thing, I've seen lots of people do art about science, but they're usually artists who are interpreting science. So I'd like to do it the other way. I'd like to be a scientist who does something that's acceptable in the arts world. There's a lady here with a hand up, by the way.
How did you come up with the idea to hook a 3D printer up to your telescope?
I'm sorry, I didn't catch.
How did you get the idea for hooking a 3D printer up to your telescope?
I don't know. I suppose, okay, so I suppose it's from my background. So when I was working with the infrared pyrometry stuff, I was doing a lot of very simple ray tracing. So I was fairly okay with optics. So when I saw these two things, so that something sort of clicked and said, well, you could make a telescope out of those. So that's how it kind of came about. And I like this term non-linear. There's a lot of people sort of, how do you do innovation? And I think the way that you do innovation is that you get a broad ideas together. There's a book that when I was younger, I read a book called Connections by James Burke, which was how a lot of things were developed, but by two people from completely different fields coming together and not appreciating what each other did until they got in conversation, and then they had an invention out of it. So yeah, for me, it was at the back of my head, I knew about optics. And then when I saw these two things, yeah, that's good. And we want something that's sort of sciencey. So it all sort of came together.
We have a question online from a second-year undergrad in aerospace engineering.
Mm-hmm.
And they ask, they plan on taking a career in astrophysics. Can I get a few words of wisdom from a great person in the field like you? And they said, oh, you had a lovely lecture. Thank you.
That's very kind. Well, I'm not an astrophysicist. I would possibly turn that around on its head, because I found the aviation industry an incredibly exciting place to be. I'm not quite sure I can help there. I mean, join the Royal Astronomical Society and follow it that way. And the obvious thing is to get a qualification and go to university and study astrophysics. And I think I've been told it's very competitive, but I don't know. I'm not an astrophysicist.
And in the UK, it starts with physics, and then you specialize in astronomy.
Yeah.
So that's where you
Yeah,
started with
I mean,
physics.
I don't. Okay, I'm a physicist, so everything's physics. You know, to me, what I was doing with cosmic ray stuff was physics. So we were interested in the power of cosmic ray to rip an atom to bits and find its components.
Just last comment, Susan says, thank you so much for your time. It's been a very inspiring talk, and they love the idea of a physicist in residence at an art gallery. Thank you so much, Mark. Thank you for being with us.
Thank you.